Who likes to do more work, get less value, increase waste, and generally have a worse quality product at the end of it? Who likes to do, in our industry, the wrong thing, but really, really well? Unfortunately, we've got a lot of people in our industry that actually do that. A superintendent on the job site, the reason why they are important is because they firefight. They solve the problems that come up at the last minute. And they are incredibly important people because we have a lot of problems. But what if we didn't have those issues? What if we could have a more efficient workflow? What if we could do more with less? And that's what Lean is all about. It's an efficient workflow. When I mentioned Lean earlier, and then the opportunity to combine BIM and Lean together, it's pretty amazing what you can do. It's a concept combined with an improved workflow. It just creates this potential for a magical process. But it is a huge challenge and it's a huge change. So what we're going to talk about is, first of all, an introduction to Lean. Then we'll be talking about the waste that we have in the current BIM process. And we like the number 6, so we'll talk about 6 wastes. And then we'll talk about the 5 lessons that we learned around implementing BIM and Lean in a collaborative way. And then, because the numbers just seem to go lower, we'll talk about 4 easy steps that we can use to implement, and we'll show you in the software how we do that at the end. There's a lot of literature about Lean. Most of it is related to the manufacturing industry, where you have this opportunity to continually improve production. This concept of continuous improvement and all of these different tools you can read a lot about. Most of it, however, is coming from the Toyota way, and it's another industry, but there's similar concepts that we can apply and that teams are applying in the construction industry. From a Lean perspective, there are a certain number of wastes. Sometimes you read about the 7 wastes, sometimes the 8 wastes, and they're identified by things like transportation, unnecessarily moving things, or things that are duplicate or producing too much, or unnecessary movement where people are in concern, or people waiting for information or waiting for things, where we have work in progress, can be waste, over-engineering, over-production. So these are all different wastes, mostly related, and these are from the manufacturing world. So we looked at the BIM workflow from a BIM management perspective, and we identified 6 wastes that I'll quickly go through. The first one is poor model scoping. We've talked quite a lot about this and how that can cause significant downstream effect where people don't understand what they're doing. We can also have over-modeling, under-modeling, gaps in modeling. We can see defects where potentially we've had out-of-sequence modeling. Let me dig into this one very briefly. On the left and the right, there are 2 models which have been coordinated. So BIM's done a great job here. Doesn't matter which one we have, right? So on the left-hand side, somebody who produced their model first, ran the electrical cable tray through, and then because somebody else either shouted louder in the coordination meeting, the piping was run over the top. The result in this situation is not a clash, which is good news, but there's additional hangers and bracing and additional welds, and if it's welded pipe, and additional bends, whereas on the right-hand side, the solution would be a lot more efficient, a lot more economical. So how do we make sure that the situation on the right-hand side occurs? We'll be talking a little bit more about the sequencing of the model as it's created and how that can be helped, how that priority system can help us. The fourth one here is waiting. So when we're waiting for other people's model deliverables, or we're waiting for a file to open because it's a large model file, unlike the CAD drawings that we're used to, or we're waiting for information from somebody, or somebody to approve something, all of this is waste. So we identify it a lot in our workflows. Not specifically for BIM, but a lot in the BIM workflow as well. And then reworking. So if we modeled something, unlike the previous example, I think number 3, where we routed it around, here, where we modeled it in a vacuum and probably totally ignoring other plans, other design teams that have made already, and we model a clash, it then ends up being, we have to move something. And that is rework, remodeling, and complete waste. And if I just pause and think about how our industry used to be without BIM, we didn't have these problems. Yeah? BIM is suddenly uncovering thousands of issues that we didn't used to have. It was somebody else's problem. We just created the 2D drawings, sent them off to the construction site, they went and built it, and that superintendent that is oh so important at firefighting, he's the one that sorted out all of these issues on site. But at what cost? Or what delay? So if we could do it earlier, that's great. But if we are doing this at all, it's waste. It's rework. It's doing something for the second time or the third time. So how can we eliminate that? And then the fourth one here, you've maybe seen this because it's had quite a few million views on YouTube. This guy, maybe he's the BIM manager, and he's trying to get his computer to open a file, or he's trying to cut a cross-section through a view and it's not playing. He's lagging, yeah. He's quite upset. I like this bit at the end. He actually goes and hicks it as well. Just pure frustration. So this is the administration burden that it can. I've been like that person. I've not actually taken my aggression out like that, but I'm sure we've all felt pretty burdened by some of the BIM responsibility or the change that we're going through. It's difficult. It is incredibly challenging to change, especially in our industry. And so they are the 6 BIM wastes that we identified. The scoping, poor model scoping, can lead to over-modeling, under-modeling. If we model out of sequence, we can end up with a clash-free model, but it might be a more expensive option. We might be waiting for information, for a file to open, etc. We might have modeled something in the wrong place and then have to fix it. And we also might be burdened by an incredible amount of either additional tasks that we didn't think we had before, or larger files that we didn't have before. So there's a burden on the administration side. So there are the 6 wastes that we identified. And as I mentioned about our journey as we learnt about Lean, we identified some lessons, and some of them related to the set of wastes that we saw in the previous set. But I'll walk through now, very quickly, these 5 lessons that we learned from understanding Lean from a production manufacturing perspective and applying that to a BIM workflow. The first one, from a Lean perspective, smaller batches are just so much better. So much better, why? So much better because there's a smaller amount of work people can understand. It's easier to define a specific scope within a smaller time period. There are potentially less dependencies between a lot of other tasks. There are less teams maybe involved. There's a lot that comes from breaking something down into smaller batches. And from our perspective in design and construction, instead of having, in the traditional world, large phases, in the UK originally and the US, there were phases of construction. Now, in the UK, broken down into stages, and even more stages actually recently in the update from a REBA perspective. But this concept of having concept design, slightly more detailed design, and then stuff ready for construction, depending on where you are in the world, they were long phases of design. And lots of interdependencies, lots of different teams, and lots of content. But what we have experienced is breaking it down into smaller stages means not only you can have a smaller set of content to manage, get done, and move on to the next stage, but you can also ensure that the teams start at the right point in time. So what you can see here is that architecture, and we've got also some civil and others starting early, but we don't start some trades until later, and their curves are later in the design process, but actually starting them at different points in time, rather than saying, okay, everybody's starting at this point because this is the phase where we're now detailing the design. Incredibly powerful, but just such a simple concept. Smaller batches. So learning that from a lean perspective. The second one is having a priority structure for the order, the sequence in which we are going to model. So instead of starting all of these systems at the same time, we have a priority. So in the real world, we don't put the floors above before we put the foundations in, or we don't expect to put the pressurized systems in until we have a structure for them to go in. So taking some part of that from the real world, from when we are building, but also some part of it from what's more flexible or what's less expensive to change. If you have a gravity system going in, that needs to have a higher priority than something that's under pressure that could route around something. However, if it's a riser delivering all of the water to the building, and it has the necessary to go from floor to the top floor, from the bottom to the top floor, that's important to set early. So even though, and this is just a visual depiction, don't take this for exactly how we should be doing things, this is just to indicate that elements should have a priority structure. And even though electrical might be up at the top and have a lower or be more flexible than others, it might be that the substation or the specific location of the electrical rooms is much more important and actually comes in here. So it's not a full system or full trade at a certain level, it's parts of their scope that operate, that need to have a set priority. And it's agreed by the project team. This is something we've seen incredibly important, and that helps to eliminate where we had the pipe routed around something with too many bends and too many more hangers and bracing required. The third one is, instead of me saying, you all have to sit down, you choose. You know what, it'd be so much easier if I sat down rather than standing up in this event. And if you choose to do it, and it's your idea, you're more likely to do something. And that concept here is from a pull perspective. If I ask who's going to be designing the plumbing system, when they would like to model, and what information they need in order to be able to start, and know what that handoff is to the next trade in that prioritized structure, and use a very visual and intuitive method and collaborative method to agree on that, and very tactile at a wall, then I'm actually going to get much more reliable promises from that, and much more likelihood that people are going to adhere to the plan. They're going to actually do what they said. So this, teams be more engaged if they're asked for their early and collaborative input, and more conversations, and the reliability of the design process will be improved. So the reliability, it's so much more reliable if you ask the person who is responsible to do it, rather than just believing that somebody's going to go and follow a plan, original plan. This one's kind of in combination, but that process that we saw, you saw a lot of sticky notes, different colored sticky notes. But one of the images, let me just quickly go back. So on this picture here and all of the others apart from this, they are all just colored sticky notes. Quite a powerful process on its own. But when you add, we mentioned it earlier, on the cards, the image, it's not just the person responsible for whatever that task is that understands what it is. Everyone else can suddenly understand because there's a picture. Picture's 1,000 words. And then you have those 1,000 pictures on those cards. So we learned that by printing cards with images, it would allow a huge amount more, much more collaboration between the parties and a lot more understanding between them. And we also learned that whilst there are an incredible amount of great pieces of software to be able to manage sticky notes digitally, you can't get better than having a conversation with somebody, standing in front of a wall, agreeing, writing down commitments to each other. But combining that with technology is actually the optimum outcome. So having the best of both worlds was another one of our lessons in that Lean journey. So there are 5 lessons learned. Breaking it down into smaller batches, number 1. Prioritizing the sequence of installing those elements, number 2. Number 3 was that collaboration and having an in-person meeting to be able to discuss and have those commitments. We were talking about that earlier in the scoping side of things. Who is responsible for what scope, or what point, and what the handover is, and what they need in order to be able to do those things. Really important to get their commitment. And understanding it's not just a blank sticky note, because when you start with a blank sticky note, you also start with blank looks on people's faces and almost zero communication. So we start with something that everyone can understand and tie in this concept of tactile in-person with technology. They were the 5 lessons that we learned. You've seen this video, so I won't run it again. But this was the result of 2 teams. One team that didn't run this process and was just told to go and start and go after it. The other team, actually both teams ran both processes. So they first of all did the one without the workflow. The second time, they implemented the sticky notes and the pull planning and the conversations. They essentially did it in the same amount of time, but the results were starkly different. And they had fewer clashes and fewer problems, and everyone understood and everyone's happy, and somebody said it was the best experience they'd had in 13 years of being a plumbing designer. So it's pretty impressive as a result. So as a technology company, we boiled that down into 4 steps. And I'm going to run through these quickly now, and then we can go into a demonstration and lots more Q&A, and hopefully that will be useful. The first one is defining a clear and visual scope. The second one, as we've seen, being able to print and interact with paper. So it has been very important for our teams to understand that with the image and the collaboration, we can come to the correct sequence. And then also combining technology to then, when everybody disperses to their own offices, still be able to update and manage those tasks. So they're the 4 that we'll be going through. The first one here, we can see in the software being able to use a visual grid and turning these on and off as you're defining what the requirements are. Number 1, very simple, very easy to create it. There are a lot of contracts required still, so the ability to print from the grid to create a PDF that's stored and archived with simple grids or your responsibilities or your information requirements as part of that output. The second one, being able to see and visualize what the scope is, but print these as cards, so we get a print off with each of the images on the cards, and with those images on those cards, cutting them up, physical, but then going through a planning process and using them to sequence the elements in the optimum sequence. And the outcome from that is a smaller set of weekly or stage-based, where we have a collection of set of weeks. It just depends on project size, etc. And being able to understand what the dependencies are, what is required, what could be combined, what are the additional requirements from other people, what's the commitment in order to, if I'm going to, I need this from you in order for me to provide somebody else this. The give and get, what are those agreements that need to occur? And then the fourth one is remembering that everybody works in another location potentially, and being able to use technology to combine the physical in-place planning and also the fact that we need to be able to update a plan on a continuous basis. And when we've collected that information, we have checklists from those cards and the ability to be able to check off what's been done on a checklist. Have we included the IFC warranty date, for example, and dragging it into completed. A very simple way of updating rather than having to update thousands of lines on a Gantt chart as well. So they are the 4 steps we identified and supported from both the technology and also a workflow perspective. Being able to define a clear scope, print those as cards, collaborate in person, and then update as you make progress. There's a lot of really interesting things that we are doing with this as well. So more on that if we want to expand in Q&A as well. So we just talked about Lean, how we want to do more with less. That would be nice. And in BIM, we identified those 6 wastes where we have rework, out of sequence working that causes the imperfect solution. We talked about the 5 lessons that we learned and what we then did with them in implementing them in those 4 steps for the workflow.